Okay, in this video we're going to talk about how to add, subtract, and multiply complex numbers. And the nice thing is, for adding and subtracting, it's exactly the same thing you would do with an x. And so let's treat it the same way that you would with an x. For instance, on this one, if you were given 3 plus 5x plus 4 minus 2x, you know that you would end up with 3 plus 4, combine those like terms, and 5x minus 2x gives me 3x. Well, if you can do that problem, then you can do this, because all this is then is 7 plus 3i. And it always is written in the format, the answer, of a plus bi. Make sure you have that format whenever you write your answer. The number with the I goes last. Over here, if you were given this instead of I, if that was an x, you would do this. You would say that's really 3 plus 5i, and then the negative would distribute, so I'd have minus 4 plus 2i, right? Minus 4 minus a negative 2i. And then you would say, well, 3 minus 4 is negative 1, combine like terms. 5i plus 2i is plus 7i. And you always write the thing with the I last. So the only time that you really need to worry about it is not addition, subtraction. That works exactly like you've been doing all along. The only time you're really going to be maybe a little bit confused is what happens when you multiply. Now we're going to FOIL. This is a FOIL problem just like you would expect. Okay? So if I did first terms, 3 times 4 is 12. Outer terms, 3 times negative 2i is negative 6i, just like it was an x. Inner terms is 5i times 4, which is plus 20i. And the last terms, 5 times negative 2 is negative 10i squared. Looks exactly like what you do with an x, right? Well, it basically is, with one exception. And it's the fact that you know that I squared is actually just a negative 1. I squared is negative 1. And you will always end up, when you FOIL, you will always end up with an I squared, the last term. So I'm going to end up with 12. Let's go ahead and do this. 20i minus 6i gives me 14i's remaining. But instead of negative 10i squared, I'm going to take this and I'm just going to flip the sign of the value here and make that a plus 10. And that's what the I squared does. Now you see that the 12 and the 10 can be added together. That ends up being 22 plus 14i. And that's how you multiply. So once again, multiplying is the only time you got to get concerned with anything, and the only reason it's different is because I squared is going to show up every time, and it'll always just change the sign of whatever you had. This became a positive 10 where it was a negative 10i squared. If that makes sense, then we're going to go on to talking about complex conjugates next.